Hi, and thanks for joining us today to kick off the live global celebration of 15 years of EC2. My name is Dave Brown, and I'm the Vice President of EC2. I started off as a software engineer on the EC2 team back in Cape Town, South Africa, when we were launching our first EC2 instance. It's been an incredible adventure. Over the past 15 years, we've not only seen our customers do incredible things with the services we provide, but we've watched them push the limits of what these tools can do. We spend so much time listening to our customers, and these insights dramatically influence how and what we build. Over the next 40 minutes, I'm going to focus on 4 critical moments in EC2's history, where these insights shaped the service that we offer today. For me, 2006 feels like yesterday, but the world looked a lot different 15 years ago. Cell phones weren't yet smart, and no one had even heard of an app store. You could probably say that the most popular phone app was Snake 2. Raspberry Pi was something you ate for dessert, and if you wanted to watch a movie at home, you had to wait a few days for it to arrive in the mail. Twitter launched in March, and the world was starting to see the significance of user-generated content. Time magazine named you the Person of the Year, recognizing the millions of people who anonymously contributed to wikis and websites, like MySpace and Wikipedia. You were also ranked first in Business 2.0's list of 50 people who matter now, while ABC News had listed bloggers as the people of the year. Amazon looked different too. We were an e-commerce company experiencing massive growth. We had just launched Amazon Prime, which offered unlimited 2-day shipping on millions of items for free, and it was a runaway success. We were looking for solutions to the complex challenges this type of growth presented and had a couple of initiatives underway. The first of those was an internal assessment of what Amazon was really good at and what set us apart. As expected, we discovered that we were really good at online retail, product detail pages, and inventory management. But we also discovered that we were really good at running our own data centers and providing reliable, scalable, and infrastructure services for our online businesses. The second initiative underway was something we called Merchant.com, where Amazon could power the online experience for our large retail customers. When we went to deliver the solution to our first partner, we quickly realized that building the solution was much harder than we anticipated. It turned out that in the early years of Amazon, we had interwoven a lot of our platform components, and in order to sell those elements as a service, we would have to work really hard to untangle them. From that point on, we became very strict about building in a service-oriented architecture, and we did it well. This mantra permeated everything we built, letting any team tap into the work that other teams had done. The third factor that played into the creation of AWS was that internal development projects were taking a lot longer than expected to complete. We were growing really fast and adding a lot of new engineers, but our delivery time on projects wasn't improving the way that we had expected. So Jeff asked Andy to figure out what was going on. Andy and team discovered that while engineering leaders thought their projects would take 2 to 3 months end to end, it was actually taking around that same amount of time just to reinvent the wheel and build out the compute or database elements that were needed for the service. Plus, every time these teams would solve the issue, their solution wouldn't scale beyond their own project. This was a huge realization for us. Everyone was reinventing the same wheel, and there was a real thirst for infrastructure services. If we were facing this issue, surely our customers were too. At the same time as these discoveries, we were also looking at how we could grow our associates business. This was a business where third-party websites were able to merchandise our products and earn a commission. The team was trying to figure out how to make sure product information was accurate and ubiquitous across all of their partner sites. We had tried lots of things, but one of the tests was to open a product detail APIs that provided raw information about a product, things like price, title, and availability. The theory was that if we decoupled the data from the presentation, the partner businesses could do more with that data than we ever could do. This led to much better conversion for those that used it. But what really surprised us was that with no promotion, thousands of developers flocked to this API and used the information for more than we could ever imagine and were hungry for more. So at the end of 2003, we took a step back and said, if we truly believe that businesses are going to be building applications on top of common services, then the operating system becomes the internet, which people now call the cloud. And this operating system would need a set of common components, similar to what we were already implementing internally. We realized we could contribute many of those pieces to the internet operating system. And with that, we decided to pursue a much broader mission, which was to provide businesses and developers with the tools and services to build almost any application and run virtually any workload. We started by setting up a development center based out of Cape Town, South Africa. The original AWS team had only 8 people, and everyone rolled up their sleeves to get things done, no matter what it involved. In fact, in the early days of building EC2, we were iterating so quickly on various prototypes that we ended up mocking a data center rack with a stack of laptops in the corner of the Cape Town office. We were so far ahead of our time that when we launched on August 26, 2006, a Friday morning, most of the comments on Reddit and Slashdot struggled to comprehend what we were doing. In the early days, we often talked about how we wanted to make compute as easy as switching on a light bulb. It may sound illogical now, but a century ago, many large manufacturers in the US were still powering their factories with in-house electricity generation. As the power grid became more available, companies began shutting down their on-site power plants because they could get power at a competitive rate when and where they needed it. It's similar to how we think about compute today. Just like the early shift that took place with the power grid, the idea that compute could be switched on and off when you needed it was way ahead of its time. Even today, electricity cannot be stored at scale in a meaningful way, and so the electricity powering this event today was generated just a few milliseconds ago. When our customers move to AWS, they instantly have access to more compute power and more resources than they could set up themselves. But they also have the flexibility to switch compute on and off just like a light switch. Before the cloud, IT departments had a very different approach to the compute hardware lifecycle. Most would purchase new hardware, set it up, use it for 3, 4, maybe 5 years, however long the service required it, or until the hardware failed, and then they would throw it away. Our early adopters of AWS brought the same methodology that they would use in their own data centers. They would launch an instance, use it for a long time, and eventually spin it down when they had a plan to move to a new instance or service. That all changed in 2008. I remember it was a Thursday afternoon in Cape Town, early morning in the US, and the launch rates on our control planes suddenly skyrocketed. We had never seen this number of instances launched or terminated so quickly, and we were working frantically to ensure that all of our systems remained healthy. Despite all the design and testing we had done, we had never seen the infrastructure we had built operate at this scale before. The growth was being driven by a new startup named Animoto. They had built a service on EC2, S3, and SQS that allowed users to upload a series of images to generate a video with music and transitions. At the time, this sort of technology was brand new. There's a lot that goes into the background to make this work. After the images have been uploaded, proprietary algorithms analyze them and then render the final video. Depending on the number and size of the images, this required a considerable amount of computing power, at least a considerable amount back in 2008. The team had introduced a new Animoto Videos Facebook application about a month earlier and had done pretty well with about 25,000 users signing up over the course of the month. However, they noticed that a significant portion of users who activated the app on Facebook never made their first Animoto video. The team at Animoto knew that their usage relied heavily on the wow factor of seeing your first Animoto video and wanting to share it with your friends. So on the Monday, the team made a subtle but important change to the application. They auto-created a user's first Animoto video. In 4 days, they went from 25,000 users to 250,000 users, and each of them had a video automatically generated. Every video would launch, use, and terminate a separate EC2 instance. For the prior month, they had been using between 50 to 100 instances. On Tuesday, the instance usage peaked at around 400. By Wednesday, it was 900, and then 3,400 instances as of Friday morning. While this was the first time we saw instances being automatically launched and terminated at this scale and in response to agile customer actions, as we know, it's a paradigm that has become commonly used in the container and serverless space today, all enabled by the cloud. In 2009, I remember us celebrating the launch of our millionth instance. It had taken us 2 years and a lot of hard work to get to this point, so when the counter clicked over, it was a huge milestone for us. Only 4 months later, we watched as EC2 surpassed 2 million instances. 2 months after that, 3 million instances. And it was about then that we stopped counting. Now, we operate at a scale we couldn't possibly have imagined when we started out. There are over 60 million new instances spun up every single day on EC2. And with this huge size and scale, we're not only able to deliver on our initial promise to support every workload better than ever before, but we're also able to help businesses respond to external challenges faster and better than they ever previously could have done. Never has that been more apparent than in the last 18 months. COVID has impacted us all, the way we learn, the way we work, the way we entertain, the way we go about our daily lives. Last year, our commute times and carpool duties were replaced with finding a quiet place to take our video calls and ensuring our kids turned in their virtual homework assignments. This put huge pressure on IT leaders to respond quickly to scale their businesses and meet demands like moving from in-person interactions and transactions to online. And this has led to an enormous demand for the cloud. AWS responded quickly by helping to provide scalable and reliable infrastructure capacity and technical support to our customers. For example, FINRA, an organization that governs the brokerage firms and exchange markets in the United States, has seen market volumes increase by 2 to 3 times. FINRA's compute resources with AWS are automatically provisioned and can process a record peak and then shut down to nothing without any human interaction. FINRA automatically turns on and off up to 100,000 new instances in a single day. Like other home entertainment services, Netflix has seen spikes in viewing and increased member growth during this unprecedented time. In order to meet this demand, Netflix's back-end services needed to scale very quickly. This is where the value of AWS's cloud and Netflix's strong partnership became apparent, both in being able to meet capacity needs in compute storage, as well as providing the necessary automation and management. Now, during this time, these spikes in capacity challenged other major cloud providers, resulting in disruptions or, just as important, customers not getting the capacity they needed for their businesses. That was not the case for AWS. AWS did not have any significant disruptions during this time, and we were able to continue to scale to the needs of our customers. Doing this was no easy feat. Managing cloud capacity to create what I call the illusion of infinite capacity is a very complex problem, and it's something that we've invested significant resources in over the last 15 years. In fact, we learned very early on just how complex capacity can be. Back in 2007, when we had an unexpected spike in capacity demand, we could solve it by terminating a few instances that the EC2 team themselves were using. The scale was that small. Today, however, we need to have complex forecasting algorithms and optimized supply chains to ensure that we have enough capacity for the huge spikes in demand that we see, sometimes overnight. Over the years, we've worked out how to operate at cloud scale, where we can cope with almost any demand and any challenge, and we never have to say no to our customers. Many of our customers provision capacity automatically, based on demand and without any human intervention. Some customers even have systems in place that can automatically turn on and off up to hundreds of thousands of compute nodes in a single day. A great example of this is a customer of ours called Blackboard. Every day, in thousands of classrooms in every corner of the world, from Shanghai to Cape Town, teachers and students depend on Blackboard's EdTech platform to advance education. Whether students are using Blackboard tools to create their own blogs or collaborate on group projects, Blackboard's platform has become an increasingly important part of the instructional landscape. In March last year, Blackboard needed to rapidly scale their systems to keep pace with the dramatic shift in online learning in response to COVID-19. Blackboard worked with us to scale their systems 50 times to support a 3,600% surge in daily global usage. I wanted to take a moment to talk through how we were able to do this, how we proactively manage the huge spikes in demand and create this illusion of infinite capacity. A lot of our ability to provide this has to do with how good we are at managing our supply chain, and that's unique to AWS. We started adjusting our supply chain to deal with the COVID-19 pandemic in early January 2020, long before many had realized the gravity of the situation. We made sure that we had supplier redundancy by shifting manufacturing to countries where the virus had less impact, allowing us to overcome any temporary disruptions. We also moved our assembly line closer to our data centers, enabling us to ramp up capacity pretty quickly. We also have strong supply chain partnerships, which would enable us to move quickly if needed. We also have a team called the AWS Forecasting Team who manage statistical models based on external factors as well as our internal signals and historical experience. For example, if there's a large video game launch or we're seeing additional demand from a video conferencing partners, we work with our infrastructure partners and our manufacturers to ensure that we have the capacity we need online in advance of these events. And So our culture of customer obsession enables us to meet customer needs as they run and grow their businesses at every scale. And this has been recognized consistently by industry analysts. For the 10th consecutive year, Gartner has placed AWS as a cloud leader in the Cloud Infrastructure Platform and Services Magic Quadrant, ahead of all other cloud vendors. Gartner's evolution of their Magic Quadrant is representative of the transformation in this space. Back in 2009, when they introduced the first Magic Quadrant that included cloud infrastructure providers like AWS, they positioned us relative to web hosting providers. Despite our grand vision for AWS, from an analyst's perspective, one of the primary use cases for cloud infrastructure was hosting simple web applications and content on someone else's servers. Gartner's journey from a Magic Quadrant of web hosting and hosted cloud systems to a new cloud infrastructure and platform services Magic Quadrant shows us how customer requirements and expectations of the cloud have evolved. At AWS, our culture of customer obsession empowers us to stay ahead of these evolving customer expectations and not only meet their needs, but predict what they might need next. When we first started, we had no idea what customers needed or wanted. We were so far ahead of our time, and nobody had really done this before. With our first instance, we mostly just made an educated guess at what would be useful for our customers. We had 3 assumptions at the time. First, customers would want to scale their infrastructure up and down based on demand. Second, customers would want to only pay for what they used. And third, customers needed just one instance type to run their workloads. We were clearly wrong about the last assumption, as today we have over 400 instances. I remember seeing the engineer responsible for the Zen configuration look at the hardware that we had at the time, do the math on how many instances we could reasonably run on a single server, and then set those numbers as our EC2 instance specification. We didn't even think to give it a name at the time. We just called it the EC2 instance. It wasn't until we launched C1 instances a little over a year later that we realized we needed to give all of our instances unique names and sizes to tell them apart. As you can imagine, we've come a long way since then. Ever since we saw the amazing things customers were building on EC2, we've been striving to build better, more diverse, and more capable instances to support every possible workload and to power new customer innovation. Customers were asking for bigger and faster servers. They wanted more memory, faster CPUs, more network throughput, and even persistent disks. Over time, they asked for GPUs and even FPGAs, so that developers can literally develop at the computer circuit level if that's what they needed for their applications. Back when we started, we used Zen paravirtualization to emulate all the hardware we exposed to the guest's operating system. Even though it had its drawbacks, paravirtualization was a great way to make what we considered performant VMs at the time. However, as we listened to our customers, we quickly realized that if we wanted to continue to innovate at the pace they required, we had to think differently. After spending years of optimizing traditional virtualization systems to the limit, we knew we had to make a dramatic change to the architecture if we were going to continue to increase performance and security for our customers. This realization forced us to rethink everything about virtualization and compute in the cloud and became the spark that created the Nitro system. In 2013, we released a new feature for EC2 called Enhanced Networking, along with the C3 instance. You can really consider this the first iteration of our Nitro system. As we iterated on this hardware, we started working with a startup out of Israel called Annapurna Labs. We were really impressed with both their people and their technology, so in 2015, we asked them to become a part of Amazon. Over a period of several years, we worked closely with the Annapurna team to develop the Nitro system by breaking apart virtualization functions, offloading them to dedicated hardware and software, and reducing costs by delivering practically all of the resources of the server to the customer's instances. Since then, the scope of Nitro has expanded and has become the technology that powers all modern EC2 instances. It's grown way beyond the days where we just handled networking, and today it does everything from storage access to encryption, monitoring, and instance provisioning. The Nitro system delivers practically all of the compute and memory resources of the host hardware to your instances, resulting in better overall performance. Dedicated Nitro cards enable high-speed networking, high-speed EBS, and I/O acceleration. Not having to hold back resources for management software means more savings can be passed on to the customer. Offloading all of this technology to Nitro makes a significant impact to the instance performance. I was part of the customer meeting right around the time we launched our very first Nitro instance, the C5 instance. C5 was our first instance running entirely from Nitro hardware and software. I was talking to a customer who required consistent clock timing at a nanosecond granularity, and they were seeing too much jitter on our C4 instances. We gave them early access to the C5 instance at the beginning of that meeting, and less than 3 hours later, the C5 instance had met all of these extreme performance requirements. On security, the Nitro system is truly unique. It was designed from the ground up to exceed our customers' security and performance requirements, and includes a dedicated Nitro security chip. This chip ensures that we can cryptographically verify and protect the software and firmware running on the hardware. With the Nitro system, hardware-based security and confidentiality protections are intrinsic to its design and implementation. There is no mechanism for any system or person outside of the host to log in or read the memory of the Nitro-based instances. I recently talked about this in a blog post we published about confidential computing. At AWS, we wanted to build the most secure platform for our customers. So when we think about confidential computing and data protection, we focus on a few different sources of threats. The first is protection from AWS as the cloud provider. At AWS, we've worked to ensure that no AWS employee could ever access or be exposed to customer data, and built multiple layers of protection to prevent this from ever happening. In fact, this is one of the core design tenets of Nitro. The Nitro system is built so that no AWS operator, even those with the highest permissions, can ever have access to customer data. There's simply no way to log into the EC2 host. Instead, all communication with the host running customer instances must occur through strictly defined, authenticated, logged, and encrypted APIs. Another attack vector we wanted to protect our customers from is from software running on their host that they don't have control over. We do this in a few ways. The virtual machines on the EC2 host are isolated both from each other and from the hypervisor itself. All device communication happens over SRIOV, so it does not have the performance impact or the attack surface that come with the software-based virtualization. Any operations that involve addressing memory, like snapshots and hibernation, use specialized agents that provide end-to-end memory encryption. We do all of this to ensure that your EC2 instances are as secure on a multi-tenant system as they are on one where you have exclusive access to the hardware. Finally, we want to offer customers a way to protect their data from threats that can happen within their own network. Whether that's unauthorized software running on a server or a rogue operator, we built Nitro enclaves so that our most security-conscious customers can ensure that their data is protected from threats, regardless of where they're coming from. Security features like the ones built into Nitro make AWS a trusted compute platform for the world's most security-sensitive applications. Customers like Crypto.com and Evervault demand the highest standards of AWS and our security. I'm proud that we're able to use technologies like Nitro to provide that to them. The Nitro system has evolved over the last 12 years from a simple enhanced networking device to a full compute platform with dedicated hardware components that offload I/O functions like virtual private cloud, elastic block store, and instance storage. Today, it's a rich collection of building blocks that can be assembled in many different ways, giving us the ability to innovate more rapidly. Because all new instances are based on the Nitro system, we can design and deliver new instance types with an ever-broadening selection of compute, storage, memory, and networking options far more quickly than ever before. We're also able to use unique designs of the Nitro system to offer innovations otherwise not possible, such as bare metal instances, VMware Cloud on AWS, AWS Outposts, and even EC2 Mac instances. Thanks to the Nitro system, we're able to offer over 400 different instance configurations. Our goal is to support every type of workload that our customers want to run. One of those unique workloads we're able to support is iOS software development. Mac on EC2 is one of those things that would not have been possible to do without Nitro. When we built our Mac instance, we used the same technology that powers the bare metal instances on EC2. With EC2 Mac, we're taking an off-the-shelf Mac Mini, attaching it to a Nitro card, and making it available to customers. Without any hardware modification or custom agents inside the operating system, developers are able to use the full resources of the Mac itself, in addition to getting all the AWS goodness like VPC and EBS support. This simply wouldn't be possible without Nitro. HPC applications are another type of workload that wouldn't be possible without Nitro. Using C5N instances on AWS, the Formula One group ran computational fluid dynamic simulations to design a new car for the 2021 racing season. These simulations utilized over 1,150 compute cores to model the aerodynamics of the cars while racing and how they interacted with each other. Formula One uses the elastic fabric adapter, which is provided by Nitro and significantly increases bandwidth and decreases latency for the most performance-intensive HPC and machine learning workloads running on AWS today. When we deployed the EC2 C3 instances based on Nitro, it was the first time we designed and built custom silicon for our data centers. The Nitro hardware has evolved a lot since then, and we've learned a lot about this process. Because we were already developing custom ARM processors for the Nitro card, we started to think about how we could make this processor technology available for our customers to use. Up until this point, ARM was still mostly used in the mobile space and single board development computers. It hadn't yet been available at scale inside the data center. We knew that ARM could improve performance at significantly lower costs for our customers. So back at reInvent in 2018, we released the A1 instance with the first generation Graviton processor. Like everything we do at AWS, we used it as a learning experience. We saw our customers used it, heard what more they wanted from it, and started working on the next generation of this AWS designed custom silicon. When we launched Graviton 2, we had to make pretty substantial improvements to meet our customers' needs. AWS Graviton 2 processors deliver a major leap in performance and capabilities over the first generation AWS Graviton processor. They deliver 7 times more performance, 4 times more compute cores, 5 times faster memory, and 2 times larger caches, and result in up to 40% better price performance over comparable x86-based instances for a wide variety of workloads, including application servers, microservices, high-performance computing, CPU-based machine learning inference, video encoding, electronic design automation, gaming, open-source databases, and in-memory caches. But beyond the specs of the processor, we also learned that we needed to integrate it with the rest of EC2 instance families. That's why we offered Graviton 2 processor on C, M, R, T, and X instance types, which are functionally equivalent to the x86 variants, but are available at a fraction of the price. Customers who switch to Graviton 2 often see 40% improvement in price performance over traditional EC2 instance hardware. Graviton processors are a key tool in driving efficiencies at scale. A great example of this is Prime Day. Every year, AWS plays a critical role in making sure that every part of our infrastructure is scaled, tested, and ready to serve our customers. Internally, we use something called a normalized instance to meaningfully compare computing power across different types and sizes of EC2 instances. This year, we increased our number of normalized instances by 12.5% year over year to a 3-region cluster composed of over 53,200 C6G instances. That sounds like a lot, but it's actually 6,000 fewer physical servers than we used in Cyber Monday 2020. It was because of the performance and efficiency of Graviton 2 that allowed us to do that. This was our first peak event that was supported at scale by AWS Graviton 2 instances, and it's a strong proof point that the ARM architecture is well suited to the data center. At this scale, the price performance advantage of Graviton 2 of up to 40% versus a comparable x86-based instance, along with a 20% lower cost, turns into a big win for us and our customers. As a bonus, the power efficiency of Graviton 2 helps us to achieve our goals of addressing climate change. But meeting customer needs doesn't stop with the custom silicon we're building on Graviton. We're also designing and building custom accelerators for machine learning workloads. Last year, we launched the Inf1 instance type, powered by the AWS Inferentia chip. We built Inferentia from the ground up to provide the lowest cost machine learning inference available in the cloud. Amazon EC2 instances based on Inferentia chips deliver up to 2.3 times higher throughput and up to 70% lower cost per inference than comparable GPU-based instances. Developers can train models using popular frameworks such as TensorFlow, PyTorch, and MXNet, and easily deploy them to Inferentia using the AWS Neuron SDK. At Amazon, we use Inferentia for the vast majority of machine learning inference workloads for Alexa. By switching to the Inf1 instance, the Alexa team was able to reduce end-to-end latency by 25% compared to when they were using GPU-based instances for Alexa's text-to-speech workloads. At AWS, we're constantly developing new hardware and software to meet our customers' needs. Our new machine learning training chip called AWS Trainium will be available by the end of the year to accelerate training workloads. We have even more exciting news to tell you about silicon innovation at reInvent in November. Our mission is to build the compute platform for every workload, and our goal has been to help businesses of all shapes and sizes not just survive, but thrive. Looking ahead, we'll continue to build the cloud for scale, price performance, and security with the global coverage you need for your applications. But we're also looking to solve new challenges. If the last 15 years were shaped by cloud computing and mobile devices, the next 15 years are going to be shaped by latency. How quickly can a device do something? How quickly can you make a decision? How quickly can your autonomous vehicle make a decision about where to turn in an emergency? How quickly can that robot on your factory line respond to a defect? That's where the innovation is going to be moving forward, and that is what we're trying to do with our hybrid and edge services. We can't move faster than the speed of light, so if we want to get to the level of latency these decisions require, we'll need to get closer to the action. That's where our approach to hybrid is setting our customers up for the next 15 years. 2 years ago, we launched Outposts to extend the cloud to on-premises environments, local zones to large metro centers, and wavelength to 5G networks. Last month, we launched Outposts in 3 new countries, making it available in 59 countries around the world and 23 AWS regions. At the last reInvent, we previewed the new smaller form factors, which will go live later this year, specifically designed for smaller capacity and location requirements. Over the next 2 days, we have an incredible lineup of sessions and EC2 experts who will cover everything from choosing the right EC2 instance to accelerating autonomous vehicle development. Don't forget to get involved and take part in our interactive sessions and talk with experts in the chat. It's been great to look back at how far we've come, and I can't wait to see how you all innovate over the next 15 years. Back to you, Nick and Rob.
The world looked a lot different 15 years ago. Cell phones weren't yet smart. DVDs came in the mail, and building a digital business meant buying and maintaining expensive physical servers. Amazon looked a lot different too. We were an e-commerce company in need of a new type of infrastructure to support rapid growth. We set out to create a common set of secure services, APIs, and developer tools that would go on to become AWS, the world's most comprehensive and broadly adopted cloud platform with Amazon EC2 at its core. It started in 2006 with a single instance. People could tap into virtually unlimited computing potential. Businesses of all sizes could move from idea to market faster without needing to build their own data center. Flash forward to today, AWS now offers over 400 instance types tailored for virtually any workload. To get here, we knew we had to radically innovate to deliver significant performance improvements and cost savings to our customers. We started by reimagining virtualization with the Nitro system, offloading capabilities to dedicated hardware and software, which allowed for faster innovation, better price performance, and enhanced security. Today, AWS supports more security standards and compliance certifications than any other cloud provider. The Nitro system accelerated our partnerships to deliver custom chips and new instance types with ever-broadening compute, storage, memory, and networking options. We also introduced our own custom processors with Graviton and machine learning chips with Inferentia, further optimizing cost and performance. As AWS grew, our scale allowed us to save money and then pass those savings on to our customers. We were able to introduce our first price cut in 2014, and purchasing options like EC2 Spot and AWS Savings Plans continue to help customers reduce and optimize costs. We're innovating with new services to extend our compute on premises, helping customers run and manage their applications wherever they are. In the last 15 years, we haven't slowed down. We've helped millions of customers, from the newest startups to the largest enterprises, lower costs and innovate faster. And together, we're just getting started.